Welcome. In this video, we'll be classifying numbers. So there are a number of different number sets. So the ones that we're going to be concerned with in this course are the integers. And if you've seen my other videos on adding, subtracting, multiplying, or dividing integers, you already know what this means. So integers are just positive and negative whole numbers. So negative 6, negative 5, negative 4, negative 3, negative 2, negative 1. Also, besides the negative and positive whole numbers, 0 is also included. So 1, 2, 3, and so on. And so the integers go indefinitely in both directions. So that's the first set that you need to be aware of. The second set that actually includes the integers is something called the rational numbers. So the rational numbers include the set of integers. So what are rational numbers besides integers? Well, these are going to be fractions. So positive and negative. These are also going to include decimals with very specific characteristics. So decimals that either end, like 3.4, that decimal ends because the last non-zero digit is a 4, or decimals that have a repeating pattern. So, for example, 2.6 repeating is a rational number because it's a decimal that repeats. There's one other type of number that you need to be aware of, and those numbers are the irrational numbers, and they're totally separate from the rationals. So irrational numbers are also going to be decimals, but they're going to be decimals with very specific characteristics as well. So these are going to be decimals that don't end, but they also don't have a repeating pattern. So, for example, the number pi is irrational. Pi is 3.14159, blah, blah, blah. Goes on forever. It has no repeating pattern, so it's irrational. Other examples of irrationals, common examples, are some square roots. Well, square roots that you don't know, that don't have whole number answers. So, for example, the square root of 2 is irrational. If you wrote this out as a decimal, it would be 1.414, and then it would go on forever without a repeating pattern. Okay, if I look at other square roots, like say the square root of 16, that would actually be an integer. Why? Because the square root of 16 is actually 4. So while it doesn't look like an integer, it actually is one in disguise. So the square roots that don't have whole number answers are going to fall in this irrational number category. Square roots that do have whole number answers are going to fall in the integer category, and because it's an integer, every integer is also a rational number. So that means the square root of 16 is also a rational number. Let me show you some other sneaky examples. So suppose I gave you the example of 4 over 2. Well, immediately you might think, well, it's just a rational number because it's a fraction, but 4 over 2 is really equivalent to just plain old 2. That means it's not only a rational number, it's also an integer, because it simplifies to a whole number answer. So just because something looks like a fraction, you have to be careful to simplify it as much as you can in order to classify it properly. Okay, let's go through some examples. So, number 1, all we're supposed to do is classify each number as an integer or not. So I want you to try 1A through E, pause the video, and then restart it when you've given it a try. Okay, so the first one, -12, well, that's a negative whole number, so that's definitely an integer. -3/4 is a fraction. We can't simplify it any, so that means it's not an integer. And what I mean by that is it doesn't simplify down to a whole number. So 32 divided by 8 is actually 4, so this one looks like a fraction. And because we have a negative, that means it's -4. Well, -4 is a negative whole number, so this is an integer. 72.58 is a decimal that ends. So because it's not a whole number, it's not an integer. And then the last one, 17, is clearly a positive whole number, so that means it is an integer. Okay, let's try some other examples. So in this next set, all we're supposed to do is classify each as a rational number or not. Pause the video and then restart it after you've given it a try. Okay, so as we said, rational numbers include all the fractions. So -7/19 is a fraction, so that's definitely a rational number. -19 pi for B, well, we discussed how pi was actually irrational. It's a decimal that never ends and doesn't have a repeating pattern. Well, anytime you multiply an integer by an irrational number, it stays as irrational. So this would be no. For C, if we look at the square root of 3, I have no idea what that's equivalent to exactly. It's definitely not a whole number, so that tells me that this guy is also irrational, so it's not rational. The next one is a decimal with a repeating pattern, and we said that any decimal with a repeating pattern is rational. And then the last one, the square root of 49, simplifies to just plain old 7. So 7 is a whole number, which is an integer, and every integer is rational. So this would be rational as well.